Alright, Assalamu alaikum everyone. Welcome to lesson number 2, which will be an introduction to what homologous series are. So, first of all, we should clarify the term homologous series. Well, in organic chemistry, homologous series is basically a group of organic compounds that differ from each other by one methylene group. Methylene is basically the CH2 group. Now, let me give you an example. One of the series which you are, or one of the homologous series which you are pretty aware of, are the alkanes. And in the alkanes, you would know that you begin with methane, and then this is followed by your ethane, which is then followed by your pentane, right? And what you see is that if you were to take out the difference between these two, you will note that there's an increase of one carbon and there's an increase of two hydrogens. Similarly, from this one to this one, from ethane to propane, you can see there's an increase of one carbon because we go from C2 to C3, and there's an increase of two hydrogens. So you can clearly see what we mean by homologous series. These are a group of organic compounds that differ from each other by one methylene group. So every successive member differs from the previous and the member to come after it by one methylene group. So I hope this thing is clear. Now, one more important thing to know is that each member of a homologous series is called a homologue. This is not very important to remember, but I would recommend that you at least know what a homologue is. Alright, the next very important thing to learn about in homologous series is, well, the compounds which do belong to the same homologous series, for example, like as we discussed, methane, ethane, and propane. What causes us to place what causes them to be placed in the same homologous series? There's something that should be the criteria, right? There's something that should be similar. Well, the first thing is that anything that comes in the same homologous series will have or share the same general formula. So, for example, I hope you're well aware of the fact that alkanes have a general formula of CnH2n plus 2. So, if you talk about ethane, propane, butane, pentane, hexane, heptane, octane, no matter which alkane you're talking about, it will fit into this basically general formula, right? So that's the first thing, that all of our members of a homologous series will fit that same general formula that we will design. So let me also give you an example of alkenes. The reason why I keep on referring to alkanes and alkenes is because this is something you have already done in your O levels. So, as you can see, that alkenes have the general formula CnH2n. So, every alkene will fit into this. And by the way, N over here is basically your number of carbon atoms. So, N is the number of carbon atoms in that molecule. Okay, the next thing is that compounds which belong to the same homologous series, they have the same functional group. So I hope you remember carboxylic acids. So carboxylic acids are something of this sort, where R is something which is an alkyl group basically. So let me give you an example. Let's talk about ethanoic acid. So in ethanoic acid, we know that its formula is CH3 COOH. This is basically your ethanoic acid. Now, in this case, you can see that this COOH, this carboxylic acid group, is basically the functional group of our carboxylic acids. So, let me also give you the example of, let's say, propanoic acid. So, in the case of propanoic acid, we have CH3, CH2, COOH, or you can also write it down as C2H5, COOH. Now, in this case, you can again see that propanoic acid also has COOH in its molecule. So, this right here is the functional group, and all of the organic compounds which are placed in the same homologous series will have the same functional group. By the way, now that we're talking about functional group, let's also talk about its definition. Well, functional groups or group is basically an atom. It can be an atom or a group of atoms. In the case of which we saw in the case of carboxylic acids, we had COOH. So, a functional group can be an atom or a group of atoms within a molecule that determines characteristic chemical properties of that molecule. Now, this is very important. The reason why this statement is important is because what it implies is that the functional group will determine the chemical reactivity or properties of that molecule. So, it will determine with which molecules reagents will this molecule react with, this organic molecule will react with. For example, carboxylic acids right over here will react with alcohols to form esters. This is again a reaction which you have already done in your O levels. So why are is this organic compound reacting with alcohols to form esters? Because of this carboxylic acid group. So this is what we mean by when we say that this is a atom or a group of atoms which will determine the characteristic chemical properties of that molecule. And because, let's imply this, because homologous series, all organic compounds in the same homologous series have the same functional group, this implies that they would also have similar chemical properties. Now, the rate of the reaction can differ for each of these molecules, because some molecules may be too big, some molecules will be too small for the reaction, and there are multiple other factors. But to put it simply, because organic compounds in the same homologous series have the same functional group, and because the functional group determines the chemical properties of that molecule, it also implies that those organic compounds in the same homologous series will also have similar chemical properties. Now let's talk about the last thing, which is that all organic compounds in the same homologous series show trends in physical properties. Now let me mention some of these physical properties. So for example, your boiling point. So your boiling point is basically one of these physical properties. It can be size, it can be weight, it can be density. All of these things are basically the physical properties, because physical properties are those which you can actually observe for a given compound or molecule. All right, so all the organic compounds in a homologous series will show trends in physical properties. Let me give you a quick example. Again, I'll give you the example of alkanes. So we have methane, then we have ethane, then we have propane, and then we have our butane, and lastly let me also draw pentane. Now these first four are gases, whereas pentane is a liquid. And what that tells us is that as we are going, and as we do go down, it's a fact, as we're going down the homologous series of alkanes, our state is changing from gases to liquids to solids. So this is one example of how these organic compounds in the same homologous series actually show a trend in their physical properties. In this case, the trend is in basically your physical state. So that's it for today. Yeah, there's just one more thing that I would want you to know, and that is it is just a little bit of a detail which you do not actually require, but I always like remember my students to remember this, and that is, what is a homologation reaction? Homologation reaction is basically a chemical process. So it means that there's a chemical reaction involved, a transfer of electrons perhaps, that converts one member of a homologous series to the next member. And just imagine, how is that possible? Let's say you have methane and you want to convert it into the next. Remember, we're converting it to the next member, yani ke successive member. So from methane, if we go to ethane, in this case, right, this reaction right here will be your homologation reaction, because you're converting one member of the homologous series to the next member of the homologous series. And a simple way to do that is to add in that methylene group, because that is what makes each compound in the homologous series differ, successive compounds. So if you are able to add this methylene group into this methane, you will end up with ethane. So that's it for this video. I hope you enjoyed it. I hope you learned a lot. If you did, then give it a big thumbs up, subscribe to the channel, and hit the bell icon, and I will see you next time with lesson number 3.